In an effort to build responsible AI, we want to think about some of the issues that might arise during the development stage. The question we'll focus on now is what data will be collected to train the model? While data offers great benefits from the perspective of those designing ML, it also carries great risks for the individuals who are contributing their data. So perhaps unsurprisingly then, there are emerging laws and regulations surrounding data collection and its use. For example, in 2018, the European Union passed the General Data Protection Regulation, or GDPR, a legislative act meant to protect individuals' privacy and prescribe ways for organizations to handle personal data. But no matter what country you reside in, it's worth taking a closer look at these regulations because it's predicted that most countries will eventually either adopt the GDPR or create legislation similar to it in the near future. There are roughly three key features to data protection: identifiability, data minimization, and notice and consent. We'll go over each of these in a bit more detail now. Identifiability refers to a requirement for data collectors to reduce and safeguard identifiable components of data as much as possible. To reduce identifiable components, we want to think about de-identification techniques. So we can either fully anonymize the data, or we could employ pseudo-anonymization or pseudonymization, which creates an alias to hide the subject's identity, but where we will retain the key to reverse this. To safeguard data, there are three things to keep in mind: data encryption, which encodes the data so that it can only be accessed with permission; secure servers, of course; and the storage location. For instance, storage in the cloud offers benefits, but in what nation is the other servers, and under what laws is the cloud operating in? That also matters. It's also important to distinguish between the different classes of data because it'll determine how careful we need to be. All data is not the same. With non-personal data, for example, like aggregated statistics, we are in the clear to use it and there are no regulations. But with personal data, which might include someone's name, location, IP address, and so forth, we need to be much more careful. And sensitive data like genetic, biometric, health data, and data that reveals race, sex, even your voice recordings, you'll need to exercise the extreme caution level. Another feature of data protection is minimization. Here, the goal is to limit data collection and the duration of storage only for the time that is required to fulfill a specific purpose. It used to be that companies would want to retain the data indefinitely, right? I mean, data in some sense has value, and we don't know in future how we might reuse that data for extracting further value. But as the influx of data increased dramatically and the cost of storage became an issue, data minimization has become more important, both practically speaking, and in terms of the laws and regulations. Questions to ask yourself are how long you'll need to keep the data to achieve the purpose, whether it's necessary or it's unnecessary, data that can be deleted, and how often will you review and delete what isn't needed. Related to data minimization is the right to be forgotten, or the right to erasure outlined in the GDPR. This states that data subjects have the right to request that their data be erased as soon as possible. But this right may be overridden in some cases. For example, when the data is needed to comply with other legal obligations or achieve some purpose in the public interest and so forth. So what does that mean for data collectors? How will it change your workflow? You will want to provide subjects with clear information and practical ways to make a request for data erasure. The third feature we'll turn our attention to is notice and consent. The aim here is to provide notice to the subjects about how the data is, we are planning to use the data, and to get their consent. So the subjects have the option to choose if they want to be involved or not. And what counts as valid consent, right? This is really important because it's how you actually execute this process. Well, this concept is very similar to informed consent that was established in the medical field. You can distinguish, a couple of different components. The decision has to be informed, meaning that the subject has sufficient knowledge and comprehension to make a decision. And this rules out lies, deceit, or partial disclosure. So you have to reveal your full intentions with how you want to use that data. The decision must be voluntary, where the subject freely chooses to give their consent, ruling out coercion or inappropriate pressure or influence. You cannot provide them some sort of incentive in terms of money or gifts so that you could try to lure them into sharing that data. And the subject must be competent, right? Having the decisional capacity required to offer consent, which rules out like children or adults, deemed to be mentally incompetent. So you have to take care of these aspects. Now, we'll turn to a related question of how the data will be collected. Right? So earlier in this course, you were introduced to some mechanisms for data collection, like crowdsourcing. That's how we built, the voice data set. Product users or even paid contributors like Amazon's Mechanical Turk. Well, you're probably aware, good representative data is crucial. So it's important to anticipate possible disadvantages of a chosen method. As Kate Crawford, the principal researcher at Microsoft and a professor at NYU Tandon, School of Engineering, has said, we need to ask which people are excluded, which places are less visible. What happens if you live in the shadow of these big data sets? For example, consider a case of data collected from product users. An app called Street Bump was designed to identify and report potholes that require repair. But since the app was deployed only on smartphones, those users tend to be young with a higher income, and the data didn't accurately reflect the number of potholes in poorer neighborhoods or those with elderly residents. So problems with data collection are closely related to issues of bias. And so we'll talk about that more in an upcoming video. Finally, collecting the right data can be complicated, costly, and even time-consuming. That's why it's especially inspiring to see a movement in the ML communities towards sharing open source, publicly available data sets, like the Mozilla's Common Voice data set that we looked at. And they even break down the demographics and provide like this nutritional label in the data set, right? So this information is practically useful for people intending to use the data set, and also makes it clear where the data set could be improved. So not only does this make working on ML much easier than before, but it also increases the accessibility because it fosters innovation and even healthy competition between companies or between research groups. And this is how we'll end up with better products that improve the world we live in.